In Lesson 7.3, you're going to be adding linear expressions, still focusing on some algebraic rules that are necessary in order to go further beyond algebra. Those basic rules are helpful so that you can apply them to real-world situations and further math content beyond algebra. So in this lesson, you're going to add linear expressions, and you're going to find the perimeter by adding linear expressions. So if we take a look at, if we scroll down here, we have a vocabulary word, linear expression. And all that means is that it's an expression where the variable in the expression is raised to the first power, okay? And that's going to come up again in a few chapters, but linear means the variable is raised to the first power, okay? And we are going to first start by adding some linear expressions. And notice here on the example, it's using some algebra tiles. Don't just dismiss this as being something you don't want to try or you think it's too confusing, because it really does do a nice job of representing how you can model these problems. So 3 x's, notice there's 3 x tiles. The plus 4 are these little guys right here. The 2x right here are the 2 tiles here, and the plus 1 is right here. And when you see that all out, it's very easy to see that there are a total of 5 x's, and then there are 5 constants, and all positive there, okay? And so you can use those tiles to add linear expressions. You can also write it as an addition problem like this, and if you prefer to do it that way, this is how that method would look, okay? So we're going to take a look at the bottom of page 305, and we have x minus 3 and x minus 4. Okay, again, if you wanted to use those algebra tiles, I could represent 1 tile for that x and 1 tile for that x. And there's a reason why those are black, because black is typically for in the positive. And I'm going to use my red. If you're in the red, that means negative. And I have 1, 2, 3 negatives here, and I have 4 more negatives here. How many total negatives do we have? That's 7, so we're going to put minus 7, and then we also have 2 x's. So this answer would be 2x minus 7 for 1a. For 1b, we have a negative x, and so that's going to be a red rod there for a negative x. And then we have 3 more negative x's right there. So I'm just going to change to black really quickly to represent the 1 for a total of negative 4x. There's 1, 2, 3, 4, negative 4 x's. And then we have a plus 1 for the final answer there. Moving on to page 306, we have at the top of the page some more tiles to model for us. Again, just take some time to look at those and see how that can be modeled using those tiles. In this picture, they have a red tile to represent negative x and the green to represent the positives. Well, 1 negative and 1 positive cancel each other out, leaving 2. Is that the same thing as taking 3x, take away 1x? Yes, it is. You still get 2x. We have 2 tiles here and 4 tiles here for a total of 6. You get the same answer by taking 4 plus 2 up here. Okay, so looking at the middle of the page, we have got it 2a. We have a negative 2x and a positive 8x. That would be a total of 6x. We have a plus 4 and a minus 4, which is 0. So we don't need to put plus 0. We can just simply put 6x. For 2b, we have negative 4x and positive 5x, leaving 1 positive x. We could either do 1x or probably just x. We have a negative 1 and a negative 3. That's a total of 4 negatives. So minus 4. 1x minus 4, or simply x minus 4 would be the simplified version. We can use this concept to solve problems like finding the perimeter. So when we have a story problem and we're trying to find perimeter and we're given the units on the side. In this case, at the bottom of page 306, we have a rectangle, and one of the sides is 5x minus 1, and the other is 2x plus 1. Don't forget, when we're doing perimeter, you have to do all of the sides, so I'm going to go ahead and fill those in on all 4 sides so we can do that. And to simplify a linear expression, we have 5x plus 2x plus 5x plus 2x. And we can write that all out, or we can simplify that. 5 plus 5 is 10, plus 2 is 12, plus 2 is 14, so 14x. We also have a plus 1, minus 1, plus 1, minus 1. Well, guess what? All of those cancel out, so our simplified algebraic or linear expression is 14x for letter A. For B, it says to find the perimeter if the value of x is 5.4. So we're just simply going to put 5.4 in for x and multiply that by 14. So we have 756 with 1 decimal place, so we have 1 decimal place. The perimeter would be 75.6 units. And we can double check that with a calculator by taking 14 times, I forgot the problem, 14 times 5.4. 14 times 5.4, 75.6. All right. Moving on to the next page, we don't have any more examples, but I do want you to look at page 307, number 16 and 17. So number 16 and 17 kind of look a little bit hairy because there's so much going on, plus we have some fractions, but don't let that scare you. We're still going to combine those like terms. So starting with 2a, we have 2a minus 1a. What's left? 1a, or just a. We have negative 1b plus 3b, just like saying negative 1 plus 3, and that adds up to be a positive 2b. Finally, we have this 4, and we have a negative 6. 4 minus 6 is negative 2.